So guys, let's begin our discussion over the JEE Main pattern exercises for 3D geometry chapter. The first question is, if the direction cosines of the line are 1 by c, 1 by c, 1 by c each, then what is the very condition which c is going to follow? Now the only thing which you need over here is the very concept of direction cosines. If I say this is L, this is M and this is N, then I know LMN are direction cosines, then L square plus M square plus N square is 1. That means 1 by C square plus 1 by C square plus 1 by C square is 1. That means you get C square equals 3, C equals plus minus root 3. So C is going to follow this condition of being equal to plus or minus root 3 if 1 by C, 1 by C, 1 by C have to be direction cosine. Next question says that the angle between a line with direction ratios proportional to 2, 2 and 1 and line joining these 2 points is what? Now when a line, suppose this is a line, it is proportional, its direction ratios are proportional to 2, 2 and 1, that means it is parallel to the vector 2i cap plus 2j cap plus k cap. This is the line whose direction ratios are proportional to 2, 2 and 1, so it will be parallel to the vector 2i cap plus 2j cap plus 1k cap, and the line joining 3, 1, 4 and 7, 2, 12. So suppose this is the line which is joining 2 points 3, 1, 4 and 7, 2, 12. Clear? Then this line will be parallel to the vector 7 minus 3, 2 minus 1, 12 minus 4. Okay? So if this line is parallel to this vector, this line is parallel to this vector, angle between the 2 lines is same as angle between these 2 vectors. Let the angle between A vector and B vector be theta. So angle between A vector and B vector, if it is equal to theta, then cos theta will be equal to A vector dot B vector upon magnitude of A into magnitude of B. A vector dot B vector, 2 into 4 is 8, right? 2 into 4 is 8 plus 2 into 1 is 2 plus 1 into 8 is 8. Upon magnitude of A into magnitude of B. This is 4 plus 4, 8, 8 plus 1, 9. Root 9 is 3 multiplied by magnitude of B vector 16. 16 plus 64 plus 1, that is 81. Root 81 gives you 9. You get 18 by 27, which is 2 by 3. So theta comes out to be cos inverse 2 by 3, and that you can see is kept over here. The angle between 2 lines is same as the angle between the vectors to which they are parallel. This concept, if you are aware about, you will be very easily decode the angle between the given 2 lines. Moving to the next question. It says that if D1, D2, D3 denote the distances of this plane from 3 distinct planes. Now understand. 2x minus 3y plus 4z, 2x minus 3y plus 4z, again 4x minus 6y plus 8z, 2x minus 3y plus 4z. All these planes are parallel to each other, and distance between 2 parallel planes, suppose I say this is the plane ax plus by plus cz plus d1 equals 0, and the next plane is parallel to this plane, so the direction ratios of both of them will be proportional. If this is the next plane having the same direction ratios A, B and C, then distance between them is given by mod of d1 minus d2 upon under root a square plus b square plus c square. Now understand, this is the plane, say P. This is the plane P and this is plane P1. Distance between P and P1 is given to you. distance between P and P1 will be, they both are parallel, D1 minus D2, 6 minus 2 whole upon under root 2 square plus 3 square plus 4 square. 16 plus 4, 20 plus 9, 29. So you get 4 by root 29. Then distance between plane P and this plane, 4x minus 6y plus 8z plus 3. Now over here directly you cannot see that the direction ratios are same. But I can say distance between plane P and plane P2. If this is my plane P2, I can write plane P2 as 2 common 2x minus 3y plus 4z plus 3 by 2 equals 0. This is my plane 2 and plane P I know it is 2x minus 3y plus 4z plus 2 equals 0. Again you can see A, B, C are matching, D1 and D2 are different. Distance is given by mod of 3 by 2 minus 2 upon again root 29. This gives you 1 by 2 root 29. Because this is 3 minus 4 which is minus 1 by 2 which is 1 by 2. So you get 1 by 2 root 29 and distance between plane P and plane 3. Plane P and plane 3, it's given to you as the distance. So this is my plane 3. Clear? This is my plane 3. So the distance is minus 6 minus 2 upon root 29 which is 8 by root 29. Question is saying what you do is you take this as D1, take this as D2, take this as D3 and then tell me what is the relationship between D1, D2, D3. One very obvious thing which is evident is, suppose I multiply 8 over here, then 2 into 4 is 8, you are going to get 4 by root 29 which is same as this and therefore I can say that 8 times D2 is D1. If 8 times D2 is D1 then option C is correct. Clear? Just the very simple concept of distance between parallel planes. But for that you first have to decode that the planes given to you in picture are actually parallel planes because their direction ratios are proportional. Clear? Pretty easy direct question. Let's move to the next. This line intersects the curve xy equals c square at z equals 0. If this line and curve are intersecting at a point where z coordinate is 0, that means that point is lying on the line and that point is lying on this curve. So suppose the point is x comma y comma 0. That's the point. This point lies on the line and it also lies on the curve xy equals c square. Firstly, because this point with z coordinate 0 is lying on this line, in place of z I will substitute 0, this equation will be satisfied. I will get x minus 2 by 3 equals y plus 1 by 2 equals 0 minus 1 by minus 1 which is 1. So x comes out to be 3 plus 2 5 and y comes out to be 2 minus 1 1. Therefore point is 5 comma 1 comma 0. But because this point is lying on the curve also, therefore it will satisfy the equation of the curve. So in place of x I will put 5, in place of y I will put 1. I don't need the z coordinate, it's 0. So I will get 5 equals c square, which implies c is plus minus root 5. So that's how I get c is plus minus root 5. So if this point is lying on this line as well as on the curve, from the line I get the coordinates of the point, I plug it in here the coordinates of the point and I get the value of c. That's how a curve and the line are basically helping me to get the point also. The question could have also asked you tell me the point. But then the relevance of the curve would have been nowhere. They have given the curve with a constant that is unknown and therefore I have been able to decode the value of that unknown constant c. Next question says the line of intersection of the plane this and plane this is parallel to which vector? Now, there can be no question more direct than this. If you have understood the concept that if there are two planes, which have a certain line of intersection, this is the line of intersection of plane 1 and plane 2, then I should know that the line of intersection of this planes is parallel to the normal vector of P1 cross normal vector of P2. So, this particular line of intersection of P1 and P2 is actually parallel to N1 vector cross N2 vector. That is it. This is the only concept required over here. What is N1? This is the normal vector N1. And this is the normal vector N2. N1 cross N2, very easy to compute. This is I cap, j cap, k cap. Then you have 3 minus 1, 1. And you have 1, 4 minus 2. This is I cap, 2 minus 4, that is minus 2. Then you have minus j cap, it is minus 6 minus 1, so minus 7, plus k cap, it is 12 plus 1, that is 13. So, you get minus 2 I cap plus 7 j cap plus 13 k cap, which is this. Minus 2 I cap plus 7 j cap plus 13 k cap. This is the very vector which is the cross product of the normal vectors of these two planes, which is parallel to the line of intersection of these two planes. So, in theory also we have done this, we have actually used this, right? And there also I had explained this very important concept that the line of intersection of two planes is always parallel to the vector which is nothing but the cross product of the two normal vectors of the two planes. Next question is, the ratio in which this plane divides the line joining these two position vectors is what ratio? So, see, there is some point whose position vector is minus 2 I cap plus 4 j cap plus 7 k cap, and another point is whose position vector is 3 I cap minus 5 j cap plus 8 k cap, right? There is a point at which this plane is passing through this line segment, and that plane is dividing this line segment in some ratio, say lambda is to 1. So, this point P is basically a point lying on the plane. This is the point where the plane is intersecting the line, and that particular intersection is dividing the line in the ratio lambda is to 1. I don't know the ratio. I am going to take the ratio as lambda is to 1 and then compute the position vector of this point. What is the position vector of this point? Suppose the position vector is a vector, or let me take it as r vector. Then r vector is equal to lambda into 3 plus 1 into minus 2. So, 3 lambda minus 2 upon lambda plus 1 I cap plus minus 5 lambda plus 1 into 4 upon lambda plus 1, this j cap. I am just using the section formula, nothing more. Lambda into 8 plus 1 into 7 upon lambda plus 1 k cap. This is my very point. Now, this point is lying on the plane, so this point is going to satisfy the equation of my plane. Plane is r dot, this is 17. So, r vector is this, 3 lambda minus 2 upon lambda plus 1 I cap plus minus 5 lambda plus 4 upon lambda plus 1 j cap plus 8 lambda plus 7 upon lambda plus 1 k cap. When in place of r vector I substitute this particular vector, this equation gets satisfied. Take the dot product, 3 lambda minus 2 upon lambda plus 1 into 1. It is just this, minus 2 into 4 minus 5 lambda upon lambda plus 1 plus 3 into 8 lambda plus 7 upon lambda plus 1. So basically this particular vector is satisfying the equation of the plane. So this is going to come out to be 17. Now you can see this entire equation is in terms of lambda. When you compute the value of lambda, you get lambda equals 3 by 10. Lambda is to 1 becomes 3 is to 10. The ratio is basically lambda is to 1, and the ratio in which the plane is dividing the line segment joining these 2 points is actually 3 is to 10. Very nice question and very easy question itself. Just a point will be there at which this plane will be dividing. So I will find the position vector of that point. Because this point is the intersection point of the plane and the line, this particular position vector of this point P will be satisfying the equation of the plane, and that is going to give me the value of lambda. Moving to the next question, after this, let's see what we have. So question number 7 says that if M is denoting the midpoint of the line segment joining A and B. So first of all, the moment there is something which can easily be decoded, let's decode it. It is 4i cap plus 5j cap minus 10k cap. And next is minus I cap plus 2j cap minus k cap. And M is exactly the midpoint. So what will be the position vector of M? 4 minus 1 by 2 plus 5 plus 2, so that is 7 by 2 j cap, and minus 10 minus 1, that is minus 11 by 2 k cap. Isn't it? 4 minus 1, you basically take this plus this divided by 2, this plus this divided by 2, right? So 4 minus 1 is 3 divided by 2, 5 plus 2 is 7 divided by 2, minus 10 minus 1 minus 11 divided by 2. This is the position vector of point M, which is the midpoint of the segment joining A and B. Next it says then the equation of the plane passing through M and perpendicular to AB vector. Okay. What is AB vector? B vector minus A vector. So it is minus 1 minus 4, 2 minus 5 and minus 1 plus 10. This is AB vector, minus 1 plus 10, that means 10 minus 1, that is 9. So now you are being asked that what is the equation of the plane passing through this point M with position vector A vector and perpendicular to this vector, that means its normal vector is this. So it is giving you everything that you require to get the equation of the plane. If I have a point through which the plane passes, that means if I have the position vector of the point through which the plane passes, and I also know the vector to which it is normal, which is this, I can very easily get the equation of my plane, which is r vector minus a vector dot n vector equals 0, which is r dot n equals a dot n. R dot n is what? Now you can see over here you have minus 5 I cap minus 3 j cap plus 9 k cap, minus 5 I cap minus 3 j cap plus 9 k cap. A dot n, a vector is this, n vector is this. When you take the dot product, what you get is minus 15 by 2, minus 21 by 2, minus 99 by 2, that is going to give you minus 135 by 2. So you can say what over here, if I talk about this particular situation, here one more thing, I actually was wanting what? When I was talking about n vector, it was AB vector, which is position vector of B minus position vector of A. A vector is what? It is 4i cap plus 5j cap minus 10k cap, and B vector is minus I cap plus 2j cap minus k cap. So you actually get minus 1 minus 4, that is minus 5, then 2 minus 5, that is minus 3, and minus 1 minus 10, which is minus 1 plus 10, which gives you 10 minus 1, that is 9. So your equation comes out to be r dot minus 5i cap minus 3j cap plus 9k cap plus 135 by 2 equals 0. Clear? Quickly note this down and then we are going to move to the next question. So guys, over here, as we have decoded the answer, but just if I make this plus, the very value of this last component is going to change, that is over here 9. How? This is plus, so you will have 1 minus minus 10, which is going to make it 11. Here also you are going to have 11, here also 11, and that is going to make your very answer being the first one. Clear? Let's move to the next question. The concept is clear. I am now being asked about the image of a point with respect to a certain plane. Okay, so image of the point with respect to the plane comes out to be what? See, if this is the point x1, y1, z1, this is your plane, which is ax plus by plus cz plus d equals 0. You know that you are dropping a perpendicular, exact same distance on the other side, you get alpha, beta, gamma as the image. Right? How do you get the image? It satisfies alpha minus x1 upon a equals beta minus y1 upon b equals gamma minus z1 upon c equals minus 2 ax1 plus by1 plus cz1 plus d whole upon a square plus b square plus c square. So we have everything, we just need to use this concept of getting the image. It will be what? So x1, y1, z1 is given to me as the image of this point. So minus 1, 3, 4. Plane is x minus 2y. So you have 1x plus minus 2y plus 0z plus 0 is 0. And I don't know the image, so alpha, beta, gamma I need to find. It will be alpha minus x1 upon a equals beta minus y1 upon b equals gamma minus z1 upon c equals minus 2 times a into x1, 1 into minus 1 plus b into y1, so minus 6 plus c into z1 plus d, that is already 0, whole upon a square plus b square plus c square, 1 square plus 2 square, that is 5, right? 2 square is 4 plus 1 square, that is 5, so upon 5. So what is alpha? You get alpha plus 1 is equal to, this is what? Minus 7. Minus 7 into minus 2 gives you 14. So 14 upon 5. Alpha comes out to be 14 upon 5 minus 1, which is 9 upon 5. Beta is what? This is 14 upon 5. So 14 upon 5 into minus 2, you get minus 28 upon 5 plus 3. This gives you minus 28 plus 15 upon 5, which is minus 13 upon 5, and gamma minus 4 upon 0, so gamma is going to come out to be 4. So you get 9 by 5 comma minus 13 by 5 comma 4. Let's see. Over here, neither this nor this nor this is the image. Answer is none of these, because your answer is 9 by 5 minus 13 by 5 and gamma being equal to 4, that's the image. So just the direct concept applied of image. Question number 9. If the line passing through these 2 points crosses the YZ plane at this point, then what is the value of A, B, C? Okay. First thing that you need is the equation of a line passing through 2 points. This is the line passing through the point 5, 1, A, and here it is 3, B, 1. Fine. I am taking this as x1, y1, z1 and this as x2, y2, z2. Equation of L. X minus x1 upon x2 minus x1 equals y minus y1 upon y2 minus y1 equals z minus z1 upon z2 minus z1. This is the equation of the line. Now it says it crosses the yz plane at the point 0, 17 by 2, minus 13 by 2. Obviously, if the line is crossing the yz plane at this point, that means this point is lying in the yz plane and this point is lying on the line. If this point is lying on the yz plane, clearly its x coordinate had to be 0. So, it is a valid thing. Now, this point is also lying on the line. Which point? 0, 17 by 2, minus 13 by 2 lies on L. So, in place of x if I put 0, y if I put, say this is x, y if I put this and z if I put this is going to satisfy the equation of my line. And so, I get x minus 5, x is 0, 0 minus 5 by minus 2, this gives you 5 by 2 is equal to y minus 1. Y minus 1 upon b minus 1 is equal to z is minus 13 by 2 minus a upon 1 minus a. Clear? Next you have 5 by 2 is equal to 17 minus 2 which is 15 upon twice of b minus 1. This is what? Minus 13 minus 2a whole upon twice of 1 minus a. Look at these two. You see that 2 gets cancelled. You have 5 is equal to 15 upon b minus 1. So, b minus 1 is 15 upon 5 which is 3. b is nothing but 4. And when you compare these two, again 2 gets cancelled. You have 1 minus a is equal to minus 13 minus 2a whole upon 5, right? Or I can say 5 into 1 minus a, which is 5 minus 5a is equals to minus 13 minus 2a. So, plus 2a plus 13 is 0. Minus 5 plus 2 gives you minus 3. And 13 plus 5 is 18. So, you get a is minus 18 upon minus 3 which is 6. A comes out to be 6, B comes out to be 4. Option number A is the correct answer. Moving on to the next question, I have this point lies on this plane. Now, step by step, let's see, let's decode stuff. Because you know too many concepts are combined and given in one question. Let's decode each and every concept. From each and every statement we can get one or the other steps. So, alpha, beta, gamma lies on this plane. So, the fact that this is lying on this plane means alpha plus beta plus gamma is 2. This I have. Because these points are going to satisfy the equation of this plane. A vector is alpha I cap plus beta j cap plus gamma k cap. And k cross A is 0. K cross A is 0. You know how to open this up? This is k dot A times k minus k dot k times A is 0. What is this? This is actually k cap. K cap dot A vector times k cap minus k cap dot k cap times A vector equals 0. K cap dot k cap is 1. K cap dot A vector is actually what? What is k cap dot A vector? A vector is this. When you are going to take the dot product of this with k cap, you will get alpha into 0 plus beta into 0 plus gamma into 1. So, you will just get gamma. So, you have gamma k cap minus A vector equals 0. Now A vector is what? Alpha I cap plus beta j cap plus gamma k cap. Gamma k cap minus gamma k cap is 0, so you get minus alpha I cap minus beta j cap is 0 vector. That means this is 0 I cap plus 0 j cap plus 0 k cap. 0 vector is this. Two vectors are same if and only if each and every component is same. So I cap component will be same. Minus alpha is 0, that means alpha is 0. Minus beta is 0, that means beta is 0. I want to find out the value of gamma. I know alpha plus beta plus gamma is 2, alpha and beta are 0 by 1. 0 plus gamma is 2, which implies gamma is 2. And therefore, your answer is that gamma is 2. Clear? Practice these questions very nicely. That's it from my side. Thank you.